Okay, so this lesson is going to be over slope fields. Okay, so in order to do a slope field, this is going to be like a graphical representation of slopes from a differential equation. Okay, so we just were working with differential equations. Differential equations are when you have dy, dx equals stuff with x's and y's in it. Okay, so we're going to use this to talk about the slope of those points. Okay, so you should have this page in front of you. Okay, so you're going to fill this out as we go. So what we're going to do is we are going to fill in the slopes, or draw a little line to represent the slope at each of the nice ordered pairs. So you do see that this is in halves. We're not going to do halves, we're just going to do whole points. So what we're going to do is we're going to pick a point. So let's say we start at the point 1, 0. So 1 being my x, y being my 0. So what I would do is I would take the x and the y values and plug them into the differential equation to find the slope, and then I'm going to draw the steepness of that slope, a little line to represent it. So it'll look like this. So at the point 1, 0, since my x value is 1, I would plug 1 into the x, so that would have a slope of 1. So I'm going to draw a short little line with a slope of 1. Okay, so then we can move on to the point 2, 0. So if I have 2, 0, my x value is 2, so that means my slope would be 2. Okay, let's try the point 0, 0. So my x value would be 0, so therefore my slope would be 0. Okay, now at the point 0, 1, my x value is 0, so therefore my slope is 0. At the point 1, 1, my x value is 1, therefore my slope would be 1. Okay, at the point 2, 1, my x value is 2, so therefore my slope would be 2. Okay, moving up here to the point 0, 2, my x value is 0, so therefore my slope is 0. If we move to the point 1, 2, my x value is 1. At the point 2, 2, x value is 2, so we got a slope of 2. So hopefully you start to realize there's a pattern here. The slope of this function is just going to be whatever the x value is. So I'm going to kind of use that pattern idea and kind of blanket statement this and make this go a lot faster. So at 2, we got a slope of 2. All those lines are going to be parallel. These all have slopes of 1, so they should all look parallel. When the x value is 0, they're all 0. When your x value is -1, you got a slope that bends back this way, -1. And then a -2, they're all -2. So those should all be parallel, those little lines. So what this is a slope field is basically, kind of think of it as a current. If you were going to pick a point and plot a point in here, the current would take it and make the function, the original function. So if I was going to pick a point like right here, those lines, those slopes would kind of be parallel to that. Then we'd have slope of 0 there, and it would curl. So you can see that this original equation would look parabolic, and it would depend on where we start to see exactly how big the parabola was, or if it was up or down or whatever. So we'll talk more about that here. Let's do another slope field. So question number 2, our differential equation is -y. So really what we're looking for is all the y values for this one. So if I go to the point 0, 0, my x value is 0, y value is 0, so if I plug 0 into -0, that's 0. If I go to the point 1, 0, my y value is 0, so again, slope of 0. 2, 0, y value is 0, so I'm just going to fill this in. All the y value is 0 to make 0. When my y value is 1, so I have the point 0, 1, if I plug 1 in here, we get -1. So in this one, all my 1s are going to be negative. All should be parallel. When my y value is 2, we have a negative 2, so all those points will be negative. Okay, when my y value is negative 1, we would plug negative 1, so negative 1 times negative is positive 1, so those are going to be positive 1. And for this one, when my y value is negative 2, negative 2 times a negative is going to be a positive 2, so we have positive 2 slopes, a little bit steeper. So for this one might look a little bit different. This one kind of starts down low. You can see the steepness is going to get closer and closer to eventually 0, right? So it might look something like that, or it could be up here and go this way. Who knows? Something like that. So imagine that as a current pulling the function. Okay, let's try one with an x and y. Let's try number 3. So if I choose the point 0, 0, my x value is 0, y value is 0, so 0 times 0 makes 0. If I go to the point 1, 0, 1 times 0 is 0. So maybe we can say anything that's 0 is going to be a slope of 0. So anything on your axes. There we go. 0. I wonder what this one could be. Alright, let's move up into the first quadrant. So if I have x value 1, y value 1, 1 times 1 is 1. If we use the point 2, 1, 2 times 1 is 2, so this is a little bit steeper. If I go to the point 1, 2, I have 1 times 2, which is also 2. If I go to the point 2, 2, that's going to have a slope of 4. Ooh, alpha 4, that's a steep one. I always like to use, like, here, this would be down 4 over 1, so I can kind of like imagine drawing that line all the way to that to help me kind of draw the steepness correctly. Alright, let's move into second quadrant. So we got negative 1 times 1. So that's going to be a slope of negative 1. At the point negative 1, 2, negative 1 times 2 is negative 2. At the point negative 2, 1, negative 2 times 1 is negative 2. And negative 2 times 2 is negative 4. A little steeper there. Okay, in the third quadrant, negative 1, so negative 1 times negative 1 is positive 1, so this one's good, goes up. At the point negative 2, negative 1, negative 2 times negative 1 is positive 2, positive 2. At the point negative 1, negative 2, negative 1 times negative 2 is positive 2. And at the point negative 2, negative 2, negative 2 times negative 2 is positive 4. Last quadrant, negative 1 times 1 is going to be a negative 1. At the point 1, negative 2, negative 1 times negative 2 is negative 2. At the point 2, negative 1, 2 times negative 1 is negative 2. And last point, 2 times negative 2 is negative 4. So that's kind of an interesting slope field. This one might look like, if we follow that current, it's going to get closer, and so maybe this one might look like this, parabolic. Kind of depends where it is. Okay, let's try our last one here. We can maybe bust through this one pretty quickly. Okay, so we got x minus y. So we're going to take the x value, subtract the y. If we start at 0, 0, 0 minus 0 is 0. At the point 1, 0, we got 1 minus 0. That's a slope of 1. At the point 2, 0, 2 minus 0 is 2. At the point 0, 1, 0 minus 1 is negative 1. The point 1, 1, 1 minus 1 is 0. the point 2, 1, 2 minus 1 is 1. Okay, at the point 0, 2, 0 minus 2 is negative 2. At the point 1, 2, 1 minus 2 is negative 1. And the point 2, 2, 2 minus 2 is 0. Okay, so one thing I notice is when the x's and the y's are the same, that's a slope of 0, so I'm going to fill in those ones. Okay, let's try the point negative 1, 0. Negative 1 minus 0 is negative 1. Okay, at the point negative 1, 1, negative 1 minus 1 is negative 2. At the point negative 1, 2, negative 1 minus 2 would be negative 3. Okay, what about negative 2, 0? Negative 2 minus 0 is negative 2. At the point negative 2, 1, negative 2 minus 1 is negative 3. The point negative 2, 2, negative 2 minus 2 is negative 4. So third quadrant, we have the point negative 2, negative 1. So negative 2 plus 1 is negative 1. Okay, at this point here, negative 1, negative 2, negative 1 plus 2 is 1, positive 1. Okay, at the point 0, negative 1 would be 0 plus 1. The point negative, or 0, negative 2, that would be 0 plus 2. Okay. The point 1, negative 1, we're going to have 1 plus 1, so that's 2. The point 1, negative 2, we have 1 plus 3, it's 3. The point 2, negative 1, that's 2 plus 1, which is 3. And last point, we have 2, negative 2, so that would be 2 plus 2, making 4. So that one's kind of an interesting one. It kind of looks like it might have like a vertical, or not a vertical, but a slant asymptote there. So something like that.
It's angular distance.
Okay, so hopefully we get this. I'm going to maybe bust through this really fast, and maybe you can pause the video and try these next two, and then see if you did these correctly. So that's what I'm going to do. I'm going to pause them, pause the video, do it, and then you pause the video. We'll see if you get the right answers for both of them, so do both. Alright, so there's the answers here. So here's the slope field for x minus, or excuse me, y minus x. You kind of get a, this appears to be some kind of asymptote here. And then number 6 really looks like a circle. Notice that anytime you're on the x-axis, so when your y value is 0, well, you can't divide by 0, so it's an undefined slope, which could imply potential a vertical asymptote, or like a vertical slope. Or it could be a function that's undefined and stops at that point. Okay, so now the second half of this lesson is now going the other way. They're going to give you the slope field, and you have to decide what the potential equation would be. Okay, so for question number 7, if you were just going to pick a spot and kind of follow the flow, which function do you think it would create? Okay, so one way for you to do this is to kind of go backwards from what we were doing before. So you can pick a point. So let's say we just pick the point, let's pick the point 1, 0. So that means I have an x value of 1 and a y value of 0, and this appears to have no slope. So which of these would create no slope? Okay, Okay, so if I have this one, it would be negative 1 over 1. That would be a slope of 1. That's not a 1. For this one, it would be 1 over 0. 1 over 0, that is an undefined, so that would work. Okay, the other one, 1/9, that would be a consistent slope. We definitely know it's not this one, otherwise all the slopes would look exactly the same. And then for this one, they would all be the x values. That would be kind of similar to the very first example that we did. Okay, so that was going to be B. Okay, so if you try number 8, okay, again, we can just pick a point. I really like the idea on this one to do the same exact thing because, again, you have no slope when your y value is 0. So that really breaks that one down, and immediately you can go back to D. Because you cannot divide by 0. Okay, so I just checked this one, and what I noticed was the answer was not D. And the reason it's not D is because it's literally impossible for you to read this, but these are blue slope fields of 0 right here. So that totally negates what I just said. So if we were now to use this, it has a slope of 0. So at the point 1, 0, which of these would result in getting a slope of 0? Would 1 times 0 equal 0? So that one would work. Let's double check, because it's possible you might get multiple answers and then you'll have to use a second point to check it. For B, you would have 0 over 1, which is 0. So this one would work. Okay, let's check C. That would be 1 minus 0, which makes 1. So that is not 1, so it's not C. If we did D, we would have 1 over 0, which is undefined, which now we know is not that because there is in fact a slope. So we know it's either A or B, so now let's choose another point. Doesn't really matter which one we want to choose. Maybe be a little strategic and use something like over here. So this would be the point 2, 1. So this slope looks like maybe 2, I would guess. Maybe 2. Definitely a positive value. Probably bigger than 1. So if we do 2, 1, would this work? 2 times 1 is 2. I would say that one works. What about this one? If we did 1 divided by 2, that makes a slope of 1/2. I would say that definitely does not look like 1/2. 1/2 would be flatter. So I'm going to negate that one and call A our solution. Hopefully that will make sense. Maybe do one more just to make sure you got this. Okay, so again, we're going to pick a spot. Doesn't matter. Might as well make an easy one, so I'm going to use 1, 0 again. Okay, so 1, 0, it looks like a slope of 1 right here. So which of these is going to result in a slope of 1, or something at least positive looking like 1? So if I plug in 1 plus 0, would that one work? Yep, that would work. I would say that's pretty close. If I try the next one, I have y minus x, so that would be 0 minus 1. That's negative 1. That's definitely not a negative slope. Not that one. If we tried this one, my x value would be, let's say, negative 1 over 0. Can't divide by 0, so that would be an undefined, and we wouldn't see a line there at all. Not that one. And the fourth option, if we did that one, we'd have, let's see, 0 over 1. 0 over 1 would make 0. That's definitely not a slope of 0. There you go. So that should get you through what you need for the worksheet today. There might be some questions that kind of elaborate further with the idea of trying to figure out what the original function is. So hopefully this worksheet will get you there.
Yes.